About scholarships. And we're told that 6 different scholarships can be awarded to 20 students. And so originally, let's start laying this out. We have n equals. And just by reading out this question, it may seem a bit strange coming out of the chute. And we're talking about 6 scholarships, and we think that about that distributed among 20 students. But really, that's a confusing way to think about it. So let's change things around and we think about, well, we have 20 students and they should be fitting into 6 scholarship spots. So if we think about it as 6 spots for 6 unique different scholarships, and they have to be unique scholarships, and it does say that different, just so that we know that there's each is a unique position, or order does matter. So clearly a permutation kind of situation. So what we could do is we could end up doing it with a fundamental counting principle. As per normal, we could say, well, we have 20 to choose from for that first scholarship, and 19 and 18 and 17 and 16 and 15, and that's all good. If we're to use the permutation question, since there's no repeats for it, in other words, for part A, I see that the student may receive no more than 1 scholarship. So in that case, there's no repeats. So we could use our permutation formula. And so we would say we have 20 students and they have to fit into 6 different spots or 6 different scholarships. And so basically what we could do is we could just lay that out as NPR equals n factorial. Always good to lay out what your rationale for your question is. So when you're working it out in your learning guide, make sure you lay out your formula. And 20p6 equals 20 factorial over 20 minus 6 factorial, which is the same as 20 factorial over 14 factorial. And so basically, this and this are the same thing. And of course, on the calculator, we could plug that in, or we could plug it in using Desmos. So either way is great. So for part A, the students could not receive more than 1 scholarship. But for part B, we have a few different more options. In other words, we have all the options that we got from part A, which I guess I didn't calculate that out here. Let me fill in the calculation for that. So we did, all this should come out to 27,907,200. And so if we are allowed to have a student winning more than 1 scholarship, then we should have more options, because we have all these existing options that we just figured out, plus the additional ones where maybe student A got scholarship 1 and 2, or 1 and 2 and 3. And so we expect a bigger number if we go with part B. So with part B, it's one of those questions where with repeats allowed, we should probably go back to our fundamental counting principle. And we can put times in here. You probably already have that. And we could have put it up here as well. And in this case, we have 20 students to choose from. But for the second scholarship, we think, well, that student who got the first scholarship, they are still in the running for the second scholarship because they're allowed more than 1 scholarship, or repeats are allowable in this situation. So we're back to 20. And in the same way, in the third case, we also have 20 because that student could have got all 5 or all 6 for all we know. So we have 20 options for all of these situations. And so what we could do is we could just say, well, that's the same as 20 times itself 6 times, or 20 to the power of 6. And so we work that out, and that comes out as 64 million. And so we expect that scenario to be more options than our part A scenario. And so indeed, this is true, 64 million versus about 28 million. And so Really, you have to think about the permutation formula as a great tool, saves some time, but the fundamental counting principle is still a tool that we're going to pull out once in a while. Because sometimes, particularly when there's repeats allowed, it's the most practical way of approaching it.